Department. There we go. Sorry, I was supposed to remember that. In the Department of Literatures, Cultures, and Languages at the University of Connecticut. He is also active in the UConn's Laboratory for Spoken Language Processing and the UConn Cognitive Science community. His research interests are at the intersection of bilingualism and second language acquisition, psycholinguistics, sociolinguistics, and language pedagogy. So take it away, Kaidi.
Hey, thank you, Anna Marie, for the nice introduction. And I'm very happy and honored to be here again. It was last year for us to present my my project on second language acquisition, but this time it's on spoken word recognition and the two different cues. Okay, let me get my screen shared. You can see it now, right? Great. Okay. All right. I'm very happy to what I have been doing and being supported in Dr. Rachel Theodore's lab, and to share what we have found in terms of the cue weighting of acoustic and contextual contextual reliance, and also very excited to share what we have found in terms of especially in terms of the individual differences here. All right, I will get started. Some background first. Listeners map acoustic speech signal to meaning. That is, listeners recognize the speech sound that form building blocks for higher levels of comprehension, such as word. As you can see here, pi. However, natural speech exhibits substantial acoustic phonetic variation, such that speech context varies. Different acoustic patterns may denote the same linguistic information, which will lead to the lack of invariance problem. Since there is no one-to-one mapping between the speech acoustics and individual consonants or vowels, in order to perceive the speech sounds. So listeners have to solve a massive computational problem. So here is an illustration. As you can see, many dots here. Consider that just one of the acoustic phonetic properties present in the speech signal. So voice onset time is VOT, which is the temporal property of stop consonants. So on a given day, a listener will hear a wide range of VOTs, as you can see here. So even for the same speech sound, either b or p. During spoken word recognition, listeners integrate different cues to solve the lack of invariance problem. As summarized in this article, listeners map phonological forms onto words in memory, take account prior probabilities, linguistic and non-linguistic contexts, including the phonetic, phonological, lexical, semantic, and syntactical structures that have been activated by the speech signal as it unfolds in time. Listeners can make use of lower level cues. For example, multiple acoustic properties affect the recognition of the voicing in English word initial stops. As you can see here, the contrast ban and pen. So the recognizing including the voice onset time, VOT, and fundamental frequency, F0 of the stop consonants, and also the duration of the following vowel. And listeners can also use higher level cues, such as lexical context. For example, the classical Gannon effect. And listeners would be more likely to hear a gift rather than kift, and more likely to hear kiss rather than gis, because they know it's a word. And especially it's the case when acoustic cues are ambiguous. So listeners could also integrate both acoustic and contextual cues in speech perception and word recognition. So taken together, listeners can use bottom-up cues, such as acoustic cues, and also top-down cues such as lexical cues to solve the lack of invariance problem and to infer the intended message. In our natural communication, the lower level acoustic phonetic cues and higher level contextual cues are often convergent, often provide redundant cues to a speaker's intent, but sometimes information conflicts. Here is an example, although it's not auditory, it's visually, but you can see how the information conflicts here, which is recently very popular on social media. Let me show the demonstration here, where you can see the car signal of Mini Cooper, signal on the left pointing to the right, and signal on the right pointing to the left. Is that left or right? And sometimes auditory information also conflicts. For example, a child still learning to pronounce the, t, or g, k. For example, when you hear accented speech, as what you're hearing now from me, my accented speech. So I just said 2 minimum pairs, the, t, and g, k. Maybe you're still confused what the 2 phonemes that I mentioned. I said is the indent, is t intent, is g in gift, is k in kiss. So in these scenarios, I think with these lexical information, you may get what I mean in the example for child language development that I just mentioned, much better than I just saying the g or k or the or t. So in these scenarios, lexical contextual information is particularly useful because of my accent to speech, because the phonetic information here is to a certain degree ambiguous. All right. So Bouchon and Yeager examined how listeners integrate phonetic and lexical cues over time in cases where these cues conflict, and also in cases where these cues converge. Here is their experimental paradigm. On the given trial, listeners heard a token from a dent, tent continuum. So it's manipulated by VOT from 10 milliseconds to 85 milliseconds, as you can see here. It is in a sentential semantic context that differentially biased listeners to interpret the token as either dent or tent. In all cases, the lexical context appeared after the critical word. The critical manipulation is the degree to which phonetic and semantic cues conflicted. So in the high conflict group, as you can see on the left, each VOT step appeared same number of times in each lexically biased context. Because in general, when we hear the, we hear short VOT. When we hear t, we hear longer VOT. So creating equal appearance of each VOT in each context is creating conflicts between the two cues, the phonetic and lexical contextual cues. In contrast, as you can see on the right, in the low conflict group, the two cues are convergent, are correlated, are natural, more natural in our communication. For the 10 milliseconds VOT, it is more the-like. And here, listeners only hear dent biasing, as you can see, they're all gray here. They only hear dent biasing lexical context, but never hear tent biasing context. So that is a low conflict group, more convergent, correlated, and natural. Here are their results. Okay, let me orient you for this graph. Proportion of tent responses as a function of VOT for the two lexical contexts. So dent in gray and tent in black. And also for either a high conflict group or low conflict group. The lexical context effect is illustrated by the displacement of the dent and the tent lexical context, namely the displacement of the black line and the gray line. So you can see that when there are more tent biasing, there are more tent responses in both high conflict and low conflict groups. What is more interesting is the distance between the black line and the gray line are different in high conflict group and low conflict group. That is, the lexical context effect is larger in the low conflict group. So put another way, when the phonetic and lexical information is more convergent, it's less conflicting, the lexical context effect is larger. Thus, here we have, not we, they. So thus, here they have observed a conflict effect by comparing the two conflicting conditions. Furthermore, the lexical effects appear to emerge over time. So here again, the tent responses on the ordinal, but now it's a function of trial from 1 to 160. The beginning of the experiment to the end, collapsing across VOTs. The lexical context effect is, again, the displacement of the dent and tent function. In the low conflict group, you see a lexical a context effect in the beginning of the experiment, and it persists to the end of the experiment. However, in the high conflict group, which is really fascinating, you see a large lexical context effect in the beginning. However, it disappeared, it dissipated over time. So here it suggests that listeners learned that, whoa, that lexical information may not be informative. That may not be relevant. It might be a trick that what experimenters has designed. So it's not helpful at all in making a decision in this task. This is why they downweighted the lexical information, or put another way, they upweighted the phonetic information. As you may remember, because the lexical context comes after the critical word, which means that lexical context is far away from the phonetic cue. So here is their example of dent biasing. When in the forest was well camouflaged, we began our hike. So it's after, and it could be the case is that their pattern just reflected the post-perceptual decision-making or strategy rather than a dynamic integration of phonetic and lexical information for speech perception. One piece of evidence against the post-perceptual decision is this study from our team. In this study, in order to find a conflict effect that comes from online perceptual processing, as opposed to the post-perceptual decision, the phonetic and lexical cues were designed temporally adjacent. As you can see here, two continuum, giz, kiss, and the gift, gift, lexical context comes at the word level, not the sentential semantic level. So temporarily adjacent to the phonetic cue. VOT again, in this case, between subjects, they also manipulated the degree of conflict, as you can see here, high conflict or low conflict. And here is the aggregated graph. It showed that listeners got the same conflict effect in single word stimuli. The context effect is larger than it's larger in low conflict condition. compared to the high conflict condition. Okay, which is a conflict effect. But even in this study, the lexical context came after the phonetic cue. So the question is, what is the role of prediction and expectation for speech perception? So it could be the cases that when lexical context comes before the phonetic cue, it will be so strong that it will attenuate the conflict effect. So here is an example you will also see in later slides. Say in a code biasing context, if the context comes before, as you can see here, the second example in the code biasing, using a needle, he altered, you have already get exposed to the semantic information. So it could be possible that it could be so strong that will attenuate the conflict effect. That is, lexical context appeared before the phonetic cues. So you will expect what to hear, which may wipe out possibly the difference of either in a high conflict situation or low conflict situation. And also in this study, they tested how individual differences are linked to broad receptive language abilities. So depending on your receptive language abilities, you may be a more phonetic or lexical semantic perceiver. Okay, I'm intending to say more, but it seems that I'm afraid I won't have enough time. So just one takeaway from here, that is, well, individuals with weaker language abilities show a larger context effect. So it holds for both high and low conflict input. And larger language abilities was driven effects were carried more by the receptive language measures. So the receptive language measures here are the two bottom ones. So understanding spoken paragraphs and semantic relationships. So again, individuals with weaker language abilities, individuals with these two weaker receptive language abilities will tend to have a larger context effect. Sorry, I don't have time to orient for this graph because the time is very limited, so I just skip that. So taken together, we have two motivations for our study. Number one, we care about order, as you can see. Say the critical word now is code. Okay. Now in a code biasing context, COAT, we already know that what will happen when the context comes after the critical word. Now we would love to see what will happen if the lexical context comes before the phonetic cue. So it could be possible that you will have predictions, expectations, what to hear, as I just mentioned, which may attenuate the conflict effect. And number two, since individual differences are related to, as I mentioned, receptive language competence, and people's receptive language competence varies, we may expect individual differences in resolving the two pieces of information, either phonetic or semantic. So some may show a larger lexical context effect, while some may show smaller lexical context effect. So are the two predictions here for our study. Here is the replication and expansion that we did. The replication condition is illustrated here. It is an after a situation, which means that the lexical context comes after the phonetic cue. As you can see here, our stimuli are critical phonetic cue, phonetic code continuum. The sentence in blue here is lexical context bias towards a code, whereas the sentence in red here is lexically context biased towards gold. So for the extension is the before situation. Likewise, Using a needle, he uttered is to bias the cold context, while with a toy he amused is to bias the gold context. The only difference here is to put the lexical context before the phonetic cues. Similarly, we also manipulated the phonetic cue and lexical context by the degree of conflicting as done previously. And a very quick and brief introduction of our participant and procedures. 180 participants recruited from Prolific. They're all monolingual native speakers of American English, between 18 and 35, no language disorder. There were 4 between subjects conditions, so 45 in each condition, by order, either after or before, or and also by conflict, either high or low. It's a web-based experiment on Gorilla. And they did 2 headphone screening tasks and a single block of phonetic identification task consisting of 168 trials separated by 1,000 milliseconds. And participants need to indicate whether they heard gold or cold. The entire procedure is about 20 minutes, and they will also receive, and they have received a compensation for their participation. So here are our results. The proportion of cold responses as a function of VOT. So for cold is in red, for gold is in blue, or it is a high conflict. A high conflict is in a solid line, or low conflict is in a dashed line. So it is the aggregated data. We did replicate the conflict effect, and as what Bouchon and Jaeger have found, and that is the lexical context effect is larger in low conflict situation compared to high conflict situation manifested on this graph. As you can see here, you will notice the distance of the dashed lines are farther than that of the solid lines. So it also holds across in both after and before conditions. And so nothing is reliable whether the context comes before or after the phonetic cue. That is, the conflict effect does not modulate or interact with the order, either before or after. So your eyes are probably tuning in to the fact that the magnitude of this conflict effect seems to be reduced in our stimuli. We will also talk about it later. That is true, but it is there. And we did not replicate the learning over time effect. The percentage of code responses on the ordinal as a function now of trials from the beginning to the end of the study, a smaller context effect for a low conflict situation compared to high conflict situation. The downweight of lexical context effect was not observed as what Bouchon and Jaeger have found. So it may suggest that our listeners and this stimulus set, that if there are any potential learning, it occurred very quickly and very early, so we are not able to measure it. As I mentioned, the primary goal of our study is to examine whether the individuals show stable differences in how they integrate phonetic and lexical contextual cues. So first, ideally, 4 patterns are illustrated here, reflecting different relative weights of the phonetic and lexical cues. So low versus high lexical weighting on the horizontal, as you see here, and low and high lexical weighting. Low and high phonetic weighting here on the vertical. It is possible listeners could be weighting both sources of information very strongly, as you can see here, strong phonetic, strong lexical. It also could be possible that listeners are not sensitive to either phonetic or lexical information. As you can see here, following my cursor here, they're not sensitive to either information. So here are our results. We have plotted the random slope coefficients for the 180 participants in the sample. And this is the metrics for how strong or how weak the context effect and how strong and weak the VOT effect the listeners have. What is striking here is we don't see people clustering in the 4 quadrants. So in principle, as you may remember, in principle, they could, right? But they could be in all the 4 quadrants. But of course, they don't have to. So in our data set, we clearly see that individuals do show a wide range of variations in the reliance or weighting of lexical context, and also wide variations of the weightings of VOT. But these two seem to come in seems to come together, seems to come in tandem, such as upweighting of lexical context Q is associated with downweighting of phonetic cues and vice versa. Here on the right, 45 participants in each between subject cell, crossing high, low conflict and after, before condition. So it's already very clear here that there's a trading relationship in individual strategies in all 4 cells. As we see here again, the trading relationship is clear, and that individual difference in this phonetic and lexical context reliance or weighting actually explained far more in this data set than we could possibly attribute it to conflict and order. As you can, as I just mentioned, the results of experiment 1 compared to Bouchon and Jaeger, we did replicate the conflict effect, but the magnitude is much smaller compared to theirs. And our participant, you can see here, their magnitude is much larger, but ours is smaller. And this is number 1. Number 2 is our participants seem to show a binary pattern of responses, not so much the graded kind of responses suggested by the aggregated data, but their study did not look into the individual differences in this way. So we have the motivations for a reanalysis of their data. In our reanalysis, we spotted an error in the script, which actually contribute to the difference of the magnitude that we have observed. We don't have time to go over it, but if you have questions, we can do it in the Q&A sessions. And also by the communication with them, we also realized that the instructions for the experiments really matter. It will kind of promote listeners' responses to either more semantic or phonetic. So we did a second experiment. So the major thing here is to look at the instructions. This is their instructions. The instructions are pretty minimal. No mention of conflicts, no mention of meaning, and no examples. However, our instructions are more has given more examples for our first experiment. Let me show a demonstration here. Oh, I may need to share my sound. Sorry, very quick. Let me share my sound. Okay, here we go. Okay, you will hear that now.
With a toy, he amused the goat. To keep it safe, he caged the goat. Using a needle, he altered the coat. With his fingers, he buttoned the coat.
Okay, this is our instruction. We have examples. So those examples actually is to make them aware, give them more consciousness of the semantics. So what we did is for experiment 2 to resemble their instructions. Pretty minimal, no mention of conflict, no mention of meaning, and no examples. So here is what we have got for experiment 2. Still, the magnitude of conflict effect, it's small. So you can see the difference of low and high. So here's a comparison here. This is their study. This is a result of their study. This is the result of our study. So you can see here, their magnitude is very strong, but ours is not that, their magnitude is big, but ours is not that big. And after we have changed the instructions to without promoting that much of the semantics, our context effect has become smaller compared to experiment 1, where we have more semantics promoted instructions. And we also did not replicate learning over time effect. And we also observed the same individual patterns in our data set in second experiment. So lastly, the take-home message here. The question we raised in the beginning is how people resolve the conflict between phonetic and lexical contextual cues. We have observed the larger lexical contextual effect given the reduced conflict between the phonetic and lexical information. So sidebar here is the magnitude is smaller to what they have found. And also we need to know that the instructions really matter, because the change of the instructions, the context effect can be larger or smaller. And so we did not find a very robust order effect. The effect is very marginal. And we have clearly seen the individual differences in phonetic or lexical context reliance, the trading relationship. This relationship explains far more than conflict in order. And we did not find the learning effect over time. We did not find listeners downweighted the lexical contextual cues as what Bouchon Jaeger has found. So they're all I have. And lastly, well, for those take-home message, it's okay if there's no take-home message from this slide, but it's important that at least for one take-home message is speech perception is cool. All right, and the last one, I will end by extending by great gratitude to UConn Laboratory for spoken language processing, and also shout out to Dr. Rachel Theodore. Without your support and help, this project could never be possible. And also to Lee Zhang, who helped me record these stimuli. And also for all the students in the lab, and especially the undergrads research assistant, in helping me decide in the beginning last semester whether it is a good English sentence, because I'm a very late second language learner of English, with a linguistically very far away a native language background. So your help really helped me a lot in making these stimuli in the beginning. So thank you all without all of your support, this project could never be possible. So I'm happy to take any comments, questions, feedback. We can make this project better, especially for something that we are not able to replicate. So thank you very much.
All right, thank you, Kaidi. That was a great talk. We can start with student questions. So if any students have questions, feel free to raise your hand. Wesley, go ahead.
Hi. Thank you for the, sorry, can you guys hear me?
Yep, you're good.
Great. Thanks, Kaidi, for the very cool talk. I will admit that I'm, a little further removed from the speaker phonetic side of language, but hopefully this question, isn't like super obvious to those who do study it. I forget, did you have a slide where you showed the learning curves for both your participants as well as Bouchon and Jaeger, like side by side?
Yeah, here it is.
Yeah, probably the learning curves instead. I think there was maybe the next slide. Yeah, those kinds of graphs.
Yeah, this is the learning effect in our data set.
Mm-hmm.
And what they have here is here. Maybe I can copy and paste here. This is theirs. So this is
right.
Yeah.
Yeah. So I think, okay, maybe looking at it now, it's maybe not as big as I thought. But I thought I saw a sort of baseline difference between both studies. Where on the first trial they sort of have already this perceptual difference, but maybe it's not showing up as well here. Did you look at individual differences according to sort of controlled for the participants at baseline? Does it make any sense at all?
Yeah,
Okay.
Probably Rachel could answer a bit more about this question. I'm not quite sure.
Kaidi, I can jump in really quick.
Yeah, Nicole.
So what's happening here is on the x-axis, we have trial on a logarithmic scale. And what that ends up doing is it amplifies the differences that are present in just the first few trials. So it's not that everybody is starting out immediately at a difference. It's just that within those first, 5 trials, a difference does begin emerging that gets amplified in the plotting.
Okay.
So yeah, it's possible that people are starting at a different baseline, but I think it's also an artifact of the plotting. Gotcha.
So in the bottom graph, those first couple trials are actually averaged, whereas in the first one, it's the first trial. Okay. Yeah, that helps. Thanks.
So we can open the floor to questions from anyone at this point. Feel free to raise your hand or put a question in the chat. Emily, go ahead.
Thanks for a really nice and very complete talk, Kaidi. You guys did a lot in this. I'm curious about, I have two questions. The first is, you found this trading relationship where people who were kind of either high on their use of, on the use of lexical context or high on the use of VOT. And you said in principle, they could use both and be very high on both. I believe you, but I'm having trouble picturing what that would look like. Oh, this might help. So you're talking about the bottom right corner here? Kaidi, I think you're muted. Is that possible?
Yeah.
Oh, no, there.
Yeah.
Okay, And can you talk a little bit, you probably said I just missed it, how you characterized the strength of those cues?
So here on the bottom right, they could be both strong in lexical and phonetic. So they could also not sensitive to and any of them. They could also, here is, you can see the two lines. So a very strong context effect, and also on the right here. But they have no change because the change of VOT. So it's a very, so some people in our data set are like this, super semantic, but not sensitive to VOT. But also people here like this, they are sensitive to VOTs, but not very clear like context effect.
Got it. So that really helps. I can sort of picture what it would look like to be really strong on both or also not use either very much. Just a technical question though, how did you quantify the strength of their cue use? Just for our interest.
To quantify the
how did you measure those axes?
We use the coefficients of the beta estimates in the data set. So in the mixed effects model, we also pull out their the beta estimates. So to do a relationship of the context and VOTs. So it's a VOT and the context is in one nested structure, and we'll pull out the slopes. We pull up the slopes and then to form the discorrelation metrics.
Okay, that makes sense. And so I guess what I sort of caught my attention is you said people aren't clustering in the quadrants. Now it is true that two of the patterns are empty. So it looks like you didn't get anybody who didn't use any cues at all, which is good. And you didn't get anybody who sort of maximally used both cues, the upper right corner. But would you really expect people to kind of, really fall into sort of, let's say what would that be, northwest and southeast quadrants? Or might you, this seems like a reasonable pattern that you found that they sort of trade off with each other. I was curious what motivated that comment about not seeing things in quadrants.
Yeah, because we didn't quite see people like if they're not using any of the cues, they may be treated as not really doing a task. So they have been like taken out from the as outliers from the data set. Other than that, I have any other thoughts.
I mean, I guess maybe the thing that is theoretically possible is the person who uses VOT a lot and also uses semantic cues a lot, sort of like our bottom right pattern here. So you're not seeing that represented in the data a lot, is what I'm hearing from you.
Yeah. Then they are like super perfect participant, like are good at everything.
Okay, I mean, this is really much for my interest. And the other question I had was about the use of the semantic context. I thought it was very clever manipulation to do it sort of before and after. Can we just go to those sentences again? So, in both of these cases, you're looking at judgments after the completion of the sentence, and they're not speeded judgments, right? You can just take as much time as you want to decide the identity.
They have a what is the time? Let me see. What did we manipulate there? Yeah.
So I guess I'm curious about two things. One thing is, how do you control for potential sort of decay of what you heard when it's at the beginning of the sentence? So you have these fine-grained things, you're maybe not quite sure what you have heard, and then you have information that might resolve it versus when that lands at the end. Do you see those? Do you see interesting ways that those might differ, sort of conceptually, in terms of what the listener is confronted with at the end of the sentence?
I didn't And could you say your question again? I didn't quite.
I'm really just asking you to kind of speculate about this. I wonder if there's something different that goes on when you have something ambiguous at the beginning and you have to hold it in memory versus when you have an expectation that's preloaded by the context and then it lands at the end. And the answer might be no, they're kind of the same. But to me, it seems like the first one you might have the situation where you have like, decay of the acoustic information going on that then is sort of boosted up by the subsequent context. And in the second, it's like you've got no information, a context, and then it will sort of immediately resolve the mystery of what that the final item is. I'm really not trying to get something out of you. I'm just kind of curious about this time course information and whether those things might be qualitatively distinct from each other.
I interviewed some of the participants after the experiment. Some of them told me that as I just mentioned, in the beginning, they will try to really use the semantic use, but later they find it is really useful, and some that are not useful. So, but just one or two say it that way. So I guess it's not very like will not did not really impact the whole aggregated pattern. Oh, Rachel is raising her hands.
Rachel, did you want to say something?
Not to interrupt. When Emily's done, I have another question.
Oh yeah, I'm done. Thank you so much. This is pretty cool stuff.
Before you get started, Rachel, I just want to let everyone know that it is past 1:10. So we totally respect your time. And if you need to leave, feel free to do that. Okay, go ahead, Rachel.
Yeah, I'll supplement. So my question is in general for the room because we do have this puzzle here, but I'll supplement what Kaidi said about, part of our focus on individual differences in this study is in part because the story from past work has been very different, that the results that were shown were really taken as evidence of integration of these two cues and also about this change over time. And so I think one thing we're seeing in Kaidi's data is there doesn't seem to be a lot of integration, that there's still, at least equal weighting of the cues. Maybe if that's how we want to model integration, is more equal weighting. We really do to see this trade-off. Emily, I totally take your point about the role of time here. That's part of what motivated Nicole's study to look at this with kind of single word stimuli. I think that there's probably some careful, post hoc exploratory analyses in order here as a function of reaction time, the delay between that. Another, and maybe also to your point, actually, I'll come back to that offline. But my question for the room is, so what got us most excited about this paradigm was that learning over time, the kind of dynamic reweighting of your reliance on these cues as a function of conflict in the input. Nicole's run 2 studies with single word level that don't show that effect. Kaidi's got 2 high-powered studies here that don't show that effect. And to some degree, I'm kind of at a loss. Like, what could explain this conflict effect if it's not learning over time? Yet we've now got, 4 studies with collectively maybe 600 participants, and we're just not seeing that. Does it mean that learning is happening, but it's so quick that we're not sensitive? It doesn't manifest, as an effective trial? Or could this conflict effect somehow be an artifact of the stimuli, like mathematically? This isn't a redundant question. It really is a puzzle to me, because I don't know how the conflict effect could emerge if it's not one of learning, yet we keep seeing it and no evidence that this is changing over time.
Yeah, I guess one thought that I have, but people can feel free to go because I know we're over, is like what does, I don't know, what does conflict even mean? Like, is it in the sense of being, more realistic? Or is it sort of like in the sense of being more consistent and there's some sort of like experiment induced like tendency to like, ultimately sort of try to figure out what's going on. And so then you're like, oh, well, they're probably just asking us about the sounds if that does emerge, but then you see different things. I don't know. I guess I just wonder like, what is the goal of this simulation, like ultimately? And I guess it's, in this case, it's to be more natural in the sentence context, but it's also interesting to think about just like in terms of consistency or, yeah, like lacking conflict as you guys as put. But those thoughts are not coherent, but it is interesting and something to keep thinking about.
Maybe as a starting point, we should plot by subject's performance over time. I'm just wondering if there's any evidence that, at the subject level, they might be changing their strategy, and maybe that goes in different directions, and that's kind of washing out those, the group level patterns. Yeah, thank you. Thank you for the insight, Anne-Marie. And I know we're over, so thank you so much, Kaidi. Great talk.
Thank you.
Yes, thank you all for coming, and we will see you next week.